Guys, happy Wednesday. I hope you all are having a smooth transition back into school. So today we're going to move on with exponents, and we're going to look at some more problems with exponents that are dealing with variables instead of just that are actual numbers raised to a power. Now we're going to look at, well, what do we do if we have algebra mixed in? We have variables, we have letters that are raised to powers. What do we do with that? Okay, so I'm going to go over here to Canvas, and don't forget to do your attendance check-ins. Those are super important. And then scroll down to the bottom of the page. And so this is actually going to be your assignment, your homework assignment that I'll take a grade on right here, this products with powers. So to do the notes, remember it's going to be in that journal file from yesterday. So I'm going to pull that up on my iPad so I can write on it. So remember, you can print this out. If you have a printer at home, it's great to print it out. You can fill in the second table of contents. So yesterday we did Unit 6, Lesson 1, review of exponents. And then today we're doing Unit 6, Lesson 2, and then we're going to do products with powers is what we like to call them. So remember, a product is something that's been multiplied. Okay, my computer is really laggy when I write on my iPad for some reason, so let me let it catch up here. So we're looking at when things have been multiplied and they have exponents, so like variables. And we're going to start off with what you know, what you understand. We're going to start off with integers, with numbers that have been raised to powers. So we're going to kind of see if we can discover along the way what we need to do here. Okay, so there's your table of contents. You can type this into the slides if you want. Or if you printed it out and you just want to keep them in a 3-ring binder or something, that's fine. Okay, so here are our notes from yesterday. Wait for this thing to catch up. Unit 6, Lesson 1, that's our notes that we filled in yesterday. So then we're going to go down to Unit 6, Lesson 2. Actually, we're going to start with what's called the zero rule, zero exponents. That's where we want to start. So I don't know if you guys remember, and you did learn this. There is a rule that has to do with what happens when we multiply, when we have a base raised to the 0 power. What does it equal? So that's what we need to remember and remind ourselves of. Hang on just a second. I'll be back in 1 second. Okay, I am back. Let me bring this back up here. Okay. So let's look at the patterns. So we know that we're going to fill in this table. So again, if you can't print this out, then just get a piece of paper and start writing this table down on the piece of paper. So we know that 4 to the 4th power means 4 times 4 times 4 times 4, which is 256. So let's fill it in. We know that 4 cubed then must be 4 times itself 3 times. Well, 4 times 4 is 16 times another 4 would give us 64. Well, then 4 squared must be 4 times 4, just 2 times. That's 16. And 4 to the 1 power, that must be 4. Well, that's just 1 4, so it's going to be 4. Well, now we're trying to figure out what is 4 to the 0 then. Wait a second. I don't know. How many 4s am I supposed to write down? How many am I supposed to multiply times themselves? Well, 0, right? So, but does it equal 0? Am I supposed to write the number 0 down? Well, let's see if we can figure out what's happening over here on the side. Let's see if we can find a pattern. So we know when we had 4 to the 4th power, it was 256. When we had 4 cubed, it turned into 64. So what happened there? What we did was we had 4 4s that were multiplied, then we had 3, then we had 2, and then we had 1. So I'm looking and seeing, let's see if we can recognize a pattern. What's happening between these numbers? How do you get from 256 down to 64? Let me see if I can bring up my calculator here. So this is what we want to see. We want to see what is the pattern. So I'm noticing over here that all we did was we multiplied by 1 less 4. Okay, so let's see if that helps out. Let me clear this out. So if I take 256 and I multiply it by 1 less 4, or I divide out of 4, what do I get? Oh, well, I get 64. My screen is a little big here. Let's see if I can make it. Goodness gracious. There we go. So I get 64. Oh, so that's interesting. Okay, so let me come back over here to my notes. So if I divide by 4, I get 64. Well, what if I divide 64 by 4? So let's go back to the calculator. Okay, let's see if the pattern continues. If I say 64 divided by 4, what do I get? Oh, I get 16. Is that the next number that we got in our solutions? It sure is. So in order to get these numbers, I needed to divide by 4. So if I say 16 divided by 4, did I get 4? Yes, I did. So there is definitely a pattern. And when you see patterns in mathematics, you need to continue the pattern. We are always looking for patterns in mathematics. So what this means is I need to continue the pattern. So if I say 4 divided by 4, well, what do you get? Well, 4 divided by 4 is 1. So that must mean 4 to the 0 power has to be 1. There's no other way to look at it. We have to keep dividing by 4 to get the next number. And that makes sense because we're multiplying by 1 less 4. This is going to happen every time. And hopefully we come to the conclusion, okay, anything to the 0 power should equal 1. So let's see if the pattern continues with the 2's here. 2 cubed is 2 times 2 times 2, which is 8. 2 squared is just 2 times 2, which is 4. 2 to the 1 is just 1, 2. Okay, so let's see if our pattern continues. To get from 8 to 4, how do I get there? Well, I need to divide by a 2. Yeah, because look, I'm multiplying by 1 less 2. So 8 divided by 2 gives me the 4. So if I say 4 divided by 2, aha, I get 2. So if I say 2 divided by 2, what do I get? I get 1. So 2 to the 0 is also going to equal 1. Well, if we could try it one more time, but I have a feeling this pattern is going to stick. 5 cubed is 5 times 5 times 5, which is 125. 5 squared is 5 times 5. Whoops. 5 times 2. 5 times 5, which is 25. 5 to the 1 power we know is just 5. Well, 125 divided by 5 is 5. That's how you get from here to here. 25 divided by 5 is 5. So if I'm going to divide 5 by 5, yep, I'm going to get 1. The pattern is going to continue. So 5 to the 0 must equal, oops, I wrote the wrong thing again, guys. My brain is not working right now. 1. So that means anything to the 0 power should equal what? It's going to equal 1. If I have 2 to the 0 power, I'm going to get 1. If I have a huge number, 1,517,230.567 to the 0 power, I'm going to get 1. If I have a to the 0 power, I don't know what a is, but I know it's some number I don't know raised to the 0 power, the answer is going to be 1. If I have x to the 0 power, the answer is going to be 1. It all has to do with that 0 exponent that we're looking at here. So if I have some crazy expression, 24 times x squared, y to the 7th, guess what that whole thing's going to equal? Big fat 1. So anything to the 0 power equals 1, and this is why. It's the pattern. So that's something to store away. That's just something you just need to remember. Anything to the 0 power is 1.
Teachers, if you have any students that are in your class that was roaring at home when we ended in December, or any last semester, please send them to the office so they can get switched back. Thank you.
Okay, sorry about that announcement. So here we go. Unit 6, this is lesson 3, but it is, you can go ahead and type into your table of contents lesson 3, but we're going to move on and do products now with powers, like I said. And if you put in for lesson 2, I forgot that I numbered these 2 different lessons, so it's no big deal. Let's look and see what we can discover here. What is the difference between 3x and x cubed? So explain and complete sentences and with examples, it says. Okay, so 3x is like saying 3 times x, right? So 3x means 3 x's, but it actually means like x plus another x plus another x. 3x means I have x 3 times. But now x cubed means that we have x times x times x. So this is the difference in powers and when you just have that number, that coefficient out front. So this is important to remember that powers mean repeated multiplication, to whereas 3 times x means we're adding up 3 x's together. It's repeated addition. So when we are given expressions like this over on the side, we want to see, okay, well, can we expand these to figure out what the answer is going to be? And so the goal here is for us to expand them and hopefully begin to see patterns emerge, okay? So like they said, 2 squared is 2 times 2, and 2 cubed is 2 times 2 times 2. So we wrote them all out and we expanded them. Well, that's really 2 multiplied times itself 5 times, because see how these things are multiplied in between each other? So this is really 2 to the 5th power. So what we want to do is we want to look at the base with the power. We're going to expand it out, and we want to see if we can collapse it back down and simplify it. And then see if we can figure out a pattern here. Okay, so we have 3 to the 4th power. Well, okay, 3 to the 4th means 3 times 3 times 3 times 3 times 3 to the 5th power. Well, that's 1, 2, 3, 4. That's 5 threes. Whoops, y'all, I keep writing the wrong thing. Okay. So how many 3's do I have? Well, that's really 3 to the 1, 2, 3, 4, 5, 6, 7, 8 to the 9th, because that's 3 multiplied times itself 9 times. Well, that seemed pretty easy. Okay, well, 11 cubed is what? 11 times 11 times 11 times, that's one of them. Now I need to do the other 11 cubed. Well, that's 11 times 11 times 11. So I really end up with having 11 to the what power? I have 1, 2, 3, 4, 5, 6 11s. 11 to the 6th. Okay, so anytime you have powers that are being multiplied times another number with a power, you can just expand them out. Take it back to the basic definition of what does the power mean? It means to multiply that thing times itself however many times, and then we can collapse it back down at the end and get a final answer. Now, I could type those numbers into the calculator and figure out their final solution, but that's not what it's asking me to do. It's asking me just to write it back as one thing, one term with a power instead of 2 terms there. Okay, so this one has 3 pieces, 5 to the 1st power. Well, that's just 1 5. Well, 5 to the 4th is 5 times 5 times 5 times 5. That's 4 of them. And then 5 cubed is another 5 times 5 times 5. So how many 5s do I have? 1, 2, 3, 4, 5, 6, 7, 8. So that's 5 to the 8th power. Okay. Well, then we have x squared times x to the 7th. Okay, so now we're getting into things where we're like, oh, I don't really know. I can't like type that in the calculator. But I know x squared is x times x times x to the 7th, which is 7 x's. 1, 2, 3, 5, 6. So I know I'm counting these, and like my computer's probably lagging and not keeping up with me, but there we go. Okay, so how many total x's did I have? Well, that's really x to the what power? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's x to the 9th. So you just took x squared times x 7th, and you said that's going to equal x to the 9th. Okay, so let's do the y's. So I have y to the 5th. Well, that's y times y times y times y times y times y cubed. Y times y times y. See how these things are all multiplied together? So then it ends up just looking like a big string of y's that are multiplied times each other. And I really end up with y to the what power? Well, I have 5, and then I wrote down 3 more, which ends up equaling 8. Hopefully you are seeing a pattern at this point. What am I doing with the powers to simplify these problems? If I wrote down 5 y's, and then I wrote down 3 more, I ended up with a power of 8. What did you do with the 5 and the 3? could you do to skip this middle section is the question. What can you do to skip the middle section? That's the shortcut. So I'm not going to do the A and the B problem. I want you to do the A to the fourth, the last two in the chart. I want you to do those by yourself. I have faith that you can figure those out. So then things get a little bit more complicated, okay? I think you figured it out so far. And if you can't figure out the shortcut, I don't want to tell it to you just yet. If you can't figure it out, then just keep going and hopefully it'll come to you. If it doesn't, I'll reveal it to you at some point. But for now, I just want you to see if you can figure it out, and then let's keep going. So look at these things. So these have parentheses. Here's the difference here. All of these problems have parentheses in them because they're telling you to take some stuff inside the parentheses and raise it to a power, which means multiply all that stuff in the parentheses, I don't care what it is, and figure it out. It's repeated multiplication. How many times do you multiply it? And then we like to rearrange it because when we multiply things, it doesn't matter what order we multiply them in, we can rearrange them. Okay, so let's look at this next one here. 4 times 6 to the fourth. Well, that's this stuff, 4 times 6, multiplied 4 times. And then I'm going to use parentheses this time instead of the dots, just because it's easier. And you can use parentheses or dots to figure the multiplication. Either one doesn't matter. Well, now what I want to do is I want to take all my 4s and I'm going to move them around. So I had 4 4s that were multiplied times 1, 2, 6 6s. Well, this is the same thing we just had a minute ago, but now I have 4s and 6s. I had 4 to the power of 4, and this ends up being 6 to the power of 4. So now you see we just have 2 pieces. We're doing the same thing. We're expanding it out, and we're taking all the bases that are the same, and we're putting them to the power that applies to them. So hopefully we're seeing a pattern again. Okay, so x times y to the fifth is really x times y. So I can get all these in here. X times y, x times y, x times y, x times y. Whoops. I get 5, 1, 2, 3, 4, 5. Well, that's really x times x times x times x times x. I'm just rearranging my stuff here, times y. And I am dropping the parentheses because I'm putting dots now instead of parentheses that mean multiplication. Well, okay. What do we have here? Well, I'm going to end up having an x as a base and a y as a base. And now I can figure out what's the powers on x and y. Well, that's really x multiplied times itself 5 times, and y multiplied times itself 5 times. So now I have simplified this. So hopefully you're beginning to see a little pattern here. I think maybe when we move on now and we do the next, I'm going to skip the next one. I'm going to go to the one that has 2 to the fifth. I'm going to do this one right here. I'm going to let you do the next one on your own. We're going to move on to this one. So this is saying this stuff 4 times. Okay, so it's saying 2 to the fifth times 5 cubed 4 times. So let me zoom in. So 2 to the fifth times 5 cubed, 2 to the fifth times 5 cubed, and then 2 to the fifth times 5 cubed. Okay, so this one might get a little long, so I'm going to zoom in. So now I'm going to rearrange. I'm going to do this in two columns here. So I have 2 to the fifth times 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 5 cubed times 5 cubed times 5 cubed times 5 cubed. Okay, so now underneath this, let me let that catch up with me. I'm going to expand this even further. My computer is so laggy, and I apologize for it because it's really, really far behind me. I've already written this whole line. So let me pause here and let this catch up with me. Okay. You'll see how I just rearranged the pieces. Even though each individual piece has a power on it, I'm still just rearranging them. Okay, so now we could expand this out even further. Now, this could get a little daunting, but that's okay because you're going to see the shortcut soon and you're not going to have to do this. So this is 2 to the fifth. Well, I could rewrite that, each one of these 2 to the fifth, as 2 times 2 times 2 times 2 times 2, right? Do you see that? So this one piece, let me get a different color here. This one piece, 2 to the 5th, I could write out as these 2's right here. Well, then I could do it again. Times 1, 2, 3, 4, 5. I could do it again and again. So let's think about this. Let's use our smart brains. If I don't want to write out all those 2's, I'm going to end up having how many 2's? To what power? How many times would I have written down 2's? Well, let me let my computer catch up again. I'm going to have 5 plus 5 more plus 5 more plus 5 more. So how many total 2's would I have? Well, 5 plus 5 is 10 plus another 5 plus another 5 is 20. So that's really going to end up being 2 to the 20th power. Okay, so now I have my 5's. Let's think about that. I would write down 3 plus 3 more plus 3 more plus 3 more. So that's really going to be 5. Well, 3 plus 3 is 6 plus another 3 is 9 plus another 3 is 12. So the goal here is to look over here, get another color, to look on this side at our powers to see how they relate to these powers here over where we started. So we can figure this out by completely expanding everything. We can do that. And we can look and see if we can figure out the pattern. Again, I don't want to tell you just yet. Like, I want you to try and figure it out. Okay, so I'm going to do one more with you. I'm going to do the a cubed. I'm going to do this one right here. Okay, so this is a cubed times b squared. And it says to do this 3 times, this stuff 3 times. So a cubed b squared. A cubed b squared. Okay, that's 3 times. So now I'm going to rewrite this, okay? I'm going to zoom in again so I can get my 2 lines here. Okay, so that's really a cubed times a cubed. I'm going to put all the a's first. Now I'm going to write all my b's. B squares, and then I have another b squared, and then another b squared. Okay, so now I want to expand this out even more. Wait just a second for my computer to catch up. Almost there. Okay, so now these exponents are not that big, so I'm going to write all these out so we can really see what's going on here. Okay, I'm going to get a different color real quick. So I have a times a times a. That's this first piece. Well, now I'm going to do the second piece. That's another a times a times a. And now I'm going to do the third one. Well, that's 3 more a's. Okay, so there's all my a's. So I end up having a to what power? Well, I have 9 a's if I count them. Then I'm going to have b to some power. Well, I have b times b times b times b times b times b. So that's a total of 6 b's. So when you have powers, you have the same base, you can end up just adding the powers together. You see 2 plus 2 plus 2 gave me the 6 over here. And 3 plus 3 plus 3 gave me the 9. Now, when you have powers outside, let's see if we could have taken an even quicker shortcut. If I had taken this 3 and multiplied it times this 3 right here, how many would I get? 3 times 3, is 9. And this 3 times the 2 on the b would give me the 6. That's the shortcut. When you have a power outside parentheses, you really can just multiply power times power. You don't ever multiply power times a base, ever. But you can multiply powers times powers. Now up above, up here, I know this was a long way, but hopefully it's helped us see why this is true. Up above, hopefully we're noticing when we don't have parentheses and we just have a base times a power times the same base to a different power, we can just add those powers up. We can write them all out. If you can't remember, you can write them all out. That's the reason why we can do this. But there you go. Now, if you want to get started on the assignment for today, you can. Feel free to do that. If I would take a look at it and try to work some of them. I'm probably going to come back tomorrow and work some of those problems for you. I may, now that I'm making the video, I may not even publish it. I really want you to work these problems right here and really get a good grasp on these. So finish out these problems, but we are going to come back and practice this some more tomorrow, and I'll show you some more examples, okay?